123K. Can take look down here. Yeah, this one. This one. Yeah. So we have completed 2 months of the monsoon, and you can see quite clearly that we're doing very well. 13% above normal in July, -9 in June, and added up to 4% above normal right now. Okay. And what are the forecast? Forecast on the right and observation on the left. You can see that the forecast was correct for the southern part of India, but completely wrong in the Haryana and Punjab, where there was heavy rainfall. That the model did not capture. But the model correctly pointed out that there will be low here, high here, but here completely missed. Now we are still going strong in the El Nino. Up to 1 degree almost of the date line. So the issue is, in spite of a strong El Nino, how come there was no effect, especially in Indonesia? India is different. Indonesia should have been there. And normally this is the velocity potential anomaly for the last 5 El Nino years. You can see clearly in El Nino in July. In July there is an ascent around the El Nino 3.4 region, just north of the equator, and an equal descent over India. That's the normal thing. That didn't happen this year. Okay? And one is not clear why. Why this year as an exception? Look at this year. It's completely different. The upper level divergence is south of the equator, not in the Indonesia, but more closer to dateline, and over Indonesia, and also part of it is ascent is on the descent over Africa. Okay. So the whole thing shifted, and there's no clear explanation of why that is so. Okay. Now, last time I presented OLR data, so rainfall data. Sulochana had a doubt about it, and that is understandable because if you're going to talk about Indonesia, rainfall anomaly does not tell you anything because Indonesia has a lot of orographic rain. If you look carefully at Indonesian rainfall data, not very extensive, unfortunately. Lots of islands are there. Some of the islands get heavy rainfall with just small change in wind direction. Okay. And some part which don't have any orography, of course, responded. So OLR is slightly better way to look at it than rainfall. But even in OLR, you can see the anomaly is along the date line, not here. Okay. So that's a big mystery. Why Nino 3.4, which is the usual reference point for all of our discussion, is not showing much of a OLR anomaly. Okay. So that is the point. Very good. And just remind you about Indonesia. You can see that this data this is a, I'm wondering why 23 August did not come there. It's a prediction, sorry, it's a prediction. So you can see that there's a lot of variation within each island, in positive and negative. Okay. Here's the forecast. Now we come to again OLR, and I want to show you that if you look at the correlation between NO 3.4 and OLR for a period of 41 years, you can see clearly the highest correlation is around 0.9, not 0.6, 0.9, okay, over NO 3.4 region, and 0.8 and opposite sign for Indonesia. This is the standard forecast anomaly, which is not happening this year. So I have not seen anybody explain this feature, and this is for September. Okay, now I want you to look at this a little more carefully. I do it month-wise because in July the peak was here. Okay? By September the peak moves to dateline, and this year it happened a little earlier. So this movement also shows there is some role being played by the change in the background state as you go due to September. Okay. Somehow I'm not in any paper. When you send paper, you visit to my attention. I'm not in a paper examining. The simple notion we have told last 40 years is heat source over the NO 3.4 that causes ascent because it doesn't know Indonesia, and that kind of story or the Walker. Okay. But Walker's anomaly is provided the basic state is at rest. The basic state is not at rest. Okay. A lot of things going on zonally. I'm not in a single paper examining how an apparent heat source over the 3.4 is affected if there is non-elastic basis. They are not seen it. We never seen it show it to be because that should have been addressed. Okay. Now this is GPCP. Although I have little doubts about rainfall data, still is very strong. Correlation of plus 0.9 over this is June to September and negative over Indonesia. But this year didn't happen. That's the whole point I want to make. Okay. Now, as far as the short-term work is concerned, I would say we have done very well. The model correctly predicted GFS from 27th July, which went above 50, coming down. Of course, this was side forecast was a little bit higher, and then it revived again till today. Was very well forecast. So shorter forecast, as always, things are going very well. And what the forecast for next week? We are coming to a pretty much a break condition because according to this forecast for coming week, starting on 4th August, it is minus 11% all India. Okay, that's pretty large thing. And so I'm sure this forecast next week we'll see that. I'm sure it'll come out right. And if you look at the forecast made by GFS with ECMWF, they agree. These are 14 days. This is not 1 week. It's 14 days now. Both identical. This is the first time I've seen both forecasts being so close to each other. Okay? This is what I meant by the certain initial conditions. The predictability is much better. This is one of them. Okay. So I'm sure next week we'll see a very similar state that most of South India will get no rain, and with some rain. Badly needed. What already Ashok Samrita, we need rain very badly is going to come, and interestingly, Tamil Nadu get some rain. But this is not showing that. The small difference on the small scale between GFS and ECMWF. Okay, and then you go to the next 2 weeks. Forecast is minus 11% from 11 to 17, minus 9%, 18 to 2. Essentially, the whole of August, of minus 10%. Which is what I would say is what we were expected in July. It got delayed by a month. Okay? This is the subtle difference that's happening. And this also agrees with what is given by NQ. That is NQ. NQ also says August will be well below normal and will continue in September. Okay? So if you look at the second forecast, they issue at the end of July, I think they did that. They did it a few days ago. And they say that rainfall average of the country as a whole, August plus September, not minus plus September, will be in this range, but with a tendency to be negative on the normal. They want to play it safe. They want to say it will be a little below normal, and it will continue. This will continue for 2 months almost. And so we'll see that. So this year has some similarities to 2015, which I always like because we started our monsoon cafe that year, and we had June plus July, it was around 430. This year it is about 460, even better. Okay? But after that came the downfall. August was well below normal. This is more like 20% below normal. And September was also below normal. Finally, we got into a drought. This year that did not happen because this is very high compared to that. 120 more. So even though it comes below normal, we come to what was the original forecast of IMD. Is within 96%. No, it may come. Okay, it all depends on how bad the break is going to be in the next 2 months. That's going to be the issue. And so we are here this year, post 65. So you can see, you look at all the past years. If you're unlucky, you can be somewhere here, in which you'll be definitely getting a drought situation. If somewhere here you're okay, it'll come to close to normal. And a few years, of course. But all these years are not El Nino years. There are only few El Nino years in this, which I don't know whether I can put any El Nino here. No, I don't see it clearly here. No, I don't see it. Okay, so it's 460 now. It requires only around another 400 somewhere here to reach within normal. Okay, and again, I want to compare what we started the discussion in the first talk. Which is these are the years where it went from La Nina to El Nino, okay? And so we're comparing with that. If you compare with that, this year is unusual because this number is very large compared to all of them, okay? Much larger. And so it's all about what happened next 2 years. And you can see that even 1925, how good the data is, it was 506 June to July. Ultimately, it came down to 80. So that's also possible. But I don't know how good the data at that period. I don't know how many rain gauges they had and how good they were. But that interesting thing is there. And I want to also point out an interesting paper I saw recently, published by Hari Prasad and others, in a new journal called Earth and Space Science, AGU journal. I didn't know it existed. There's a new journal there. And what he's showing there is, this is the standard sleep with the simulation, which all of us know as a huge drawback. Okay. Then they couple a WRF model, what they call dynamic dump skull around India, to a mixed layer model. Because you know that all these troubled models have excess cold bias, which makes Arabian very cold, water vapor very low, and all that adduction is not occurring. So they want to change that. They use a green is the WRF ocean mixed layer model. Immediately the rainfall follows exactly the observation, which is in black and IMD and trim, very good up to July, and suddenly the overshoot. I don't know why. This part is interesting. The WRF produces too much rainfall. Okay? But this clearly shows the weakness in CFS2 is not in land, it is the ocean to the west. Until that SST is not corrected, you're not going to remove the dry bias. And then they talk about the temperature gradient. But I want to warn you, although this is very popular, temperature gradient does not follow rainfall increase. Okay? There are differences here in delta T between these two, because they are very small, so there's a difference. So this doesn't follow exactly what you see here.
So just do they correct? Do they put the ocean mixed layer model only on the Arabian Sea or everywhere?
I remember only Arabian Sea. No, I think that's all oceans around, because the WRF model is there over this Indian region. Right. Wherever the ocean, they want to the same one. Yeah. One has this paper. Now look at it.
It's a very large change.
Huh?
It's a very large change in the rainfall.
Yeah. Okay, so I'll come to stop there, and we will. Who is going to be next week? Okay. So, any questions on this?
Yes, sir. What is your idea about we have shown from 2015 to 23, and the July rainfall is the highest amount and by a far margin. So, what's your idea? What was?
Right. Nobody has explanation when the Nino demand was so strong and so sheer. Why it is not a part of India? India is not coming. They are all taken. Why Indonesia is not having descent around the sun? So I'm only putting hypothesis, I'm not proving it. I'm saying basic state is different from what it was in all the PNA nodes. And I'm not showing it here. You can do the anomalies, the zonal, and they are different this year.
And why? Another question is the peninsular India got a lot of rain. Because mostly, and you showed, I also showed there, the Gangetic plain doesn't it's a very dry condition till now. Yeah. And I guess the fast clear cut low pressure system is just now today moving over the southern Bengal. Yeah. So that's the first one.
The first one, you are right. After the cyclone, nothing happened.
Nothing, yeah. Yeah. This kind of pattern I have seen in many years that the low pressure systems usually go from South Odisha or the Andhra, that region. But in the second half, it comes over the Gangetic plain, where you are saying the kind of wet condition you are seeing. So, do you have any idea why? I mean, in some cases, the low pressure system moves in the north.
I have no experience. I have no what you call understanding of synoptic scale movement. What happened? I focus on monthly season scale. That's my focus. Okay. To me, it talks about smaller scale.
So it seems like some monthly scale thing is dictating that, because first 2 months.
No, this was viewpoint. My viewpoint always that way. On monthly longer scale, energy budget controls everything else. Okay? Everything else is secondary. But I'm sure people in the center and others don't believe me. They think synoptic controls the monthly mean. But I believe the monthly mean is mean are determined by energy budget and not synoptic is slave to the energy budget. That's my view. Okay? So I don't understand explaining things. For example, I remember 2002 when it took discussion, people said it was dropped here because there was no difference we have involved. There's no explanation to me. What explanation? There are many years also, but no difference in the rain. So to me, depending on an experiment with a synoptic scale, seasonal mean to me is not very useful. Okay.
Yes.
Doesn't help you.
Yeah.
But you're right. You don't answer what happened next week. Yes, synoptic is very important. You know what to say today, where is going tomorrow. But we're talking about why July was above normal. Because there no system, right? Still went above normal, and all kinds of rain occurred in Chandigarh and other places in Gujarat, and without anything coming from
Previously.
So one, of course, very what you call similar what you call disable the mid-latitude. I don't accept that also. We that also that once the monsoon comes in to say that it is due to just the mid-latitude to me is a chicken egg problem. Because the monsoon is strong, it shifts the thing. The monsoon is weak, something will come from there. So again, it is which is stuff we don't know.
So is there any initial idea about the Delhi rain? The Delhi and the Himalayas region, the rain, the flood we had there. Is there any initial idea why it's so strong flood and rainfall happened just 2 weeks, 3 weeks back?
No, I don't think anybody has found any explanation of that. But I tell you another interesting thing which all of us notice that the intensity of rainfall occurring in this region is becoming higher and higher. And now we find there is long breaks. So this is the phenomenon of climate change all over the Pacific. That whenever rain occurs, it is about double the normal intensity, and then because the total moisture is conserved, it can converge. Ultimately, you have a long break. That's what we have now. I'm sure about that. That is because of the large scale moisture conservation. It is going to continue on in the high rainfall that's occurring. So this, I think, is a very serious issue. We should discuss how if this is going to continue to happen year after year, then we get 8 millimeters, but it will all occur in that. Actually, what is not clearly, number of rainy days is decreasing in all climate models. But the rainfall is constant. So the intensity is going up. So that's what happening in Delhi, all that places. But nobody explains that event. I'm sure somebody look at it after the event and try to. But right now, nobody has given an explanation why it happened. Some people just from mid-latitude, I don't think there's evidence of that. Okay.
Yes, I have a question.
Yeah.
If you please put your ECMWF maps, you can ECMWF,
Yeah.
the map with the percent change.
Yeah.
You can please show
Sure.
that.
Yeah.
That one. So I've been attending the monsoon mostly online. That blue color in Burma has been there every week after week. And the blue color.
Yeah, let me tell you, that is one warning to all the students also. Although percentage anomaly is very convenient in certain ways, it is dangerous because where rainfall is very small, it will go to very large value. So that problem is there.
Myanmar.
Yeah, Myanmar also. This problem is there. I don't know whether it's missing data or low rainfall. I don't know. I don't know much about Myanmar. But this is there in both of them.
Every week it's there.
Yeah. So I think this is the problem when you do anomaly in a region with low rainfall. Anomaly suddenly looks very large. Or Pakistan also looks very. Last time we see some huge blue spots here because the low rainfall area suddenly rainfall goes to Tannabam and shows up. Yeah, there's not a good way to show it, but I think I would have preferred millimeter per day. But I think these guys are doing it because there's a question of mean state. The mean state in both worlds are not same. So if you show millimeter per day, it may not be the same. But you are right. I don't like percentage deviation because that is gives too much weightage to low rainfall regions. Yeah. Again, and you're right. Nobody pointed out. Month after month, this is going up. I don't know why. I have seen it for the last 10 years. So only question is, I think, I don't know how good the data from Myanmar, I don't know. It has been a closed country for 50 years, and what data is getting, and whether the climatology is right or not, we don't know. Yeah, that's a big point. I will again look and see whether I can figure out anything on that. Next time I'll show you the actual rainfall. That also shows. That may be better.